Hello students, welcome to Dr. Sourav's classes. So in this particular video, you know that we are solving the paper from UPSC, this maths optional paper, and at this moment we are solving this paper 1 of 2021, and this is from section B. So in the previous video we have solved this 5A and 5B, and so this is the part C of the question number 5. So let's see the question what is given. So two rods LM and MN are joined rigidly at the point M such that LM square plus MN square is equal to LN square, and they are hanged freely in equilibrium from a fixed point L. So let omega be the weight per unit length of both the rods which are uniform. Determine the angle which the rod LM makes with the vertical direction in terms of the length of the rods. Right? So this is the question. So you have to find the angle. So the picture that you can see on the this right hand part. Okay. So this is for the this illustrative purpose. So the thing is that, just hold on. So here you can see that the LM, this is the red stick, this is a line, and MN. Okay, so this is N. Okay, so this LM and MN be these two uniform rods. LM and MN. So the length of LM is A and length of MN is B, right? And they are rigid jointly at M. Got it? So that this angle of LMN that we have is equal to 90 degree, right? So let the rods hang freely in equilibrium from the fixed point L, as you can see. So this is the fixed point. So hanging freely in equilibrium from the fixed point L. Okay, now how the rods can be in equilibrium? So that this rod will be in equilibrium under the action of the following three forces. So what are the following three forces? So first one, that is, we have the omega A. There's condition for equilibrium, actually this is. So this is omega A, that is the weight of the rod LM. Okay, so this is the omega A, you can see. So weight of the rod LM, okay, acting vertically downwards. So this is vertically downwards at the point G1. So this is G1, right? Next is the omega B, as it is as you can see here. So that is the midpoint of G2. So the number 2 force is, sorry, this is omega B. So this is omega B. So that is the weight of the rod. So this weight of the rod is which rod? MN. So this is also acting vertically downwards at its middle point G2. So these are the two forces, and finally that is the R. Okay, so in the figure R you can note from this, that is in the upward direction, the vertically upward direction. So that is R. So R is the reaction. Okay, reaction at the fixed point L, right? So since the two forces, this omega A and omega B, these are parallel, so the third force R will also be in parallel, and this is working in the vertical direction. right? So these are the three conditions to keep the rod L in from the fixed point in equilibrium. Now given that we have this MLA is equal to theta, this MLA equal to theta, okay, and this LGB, angle of LGB is equal to angle LGB equal to theta, okay. So also this angle of DMN, so the angle LGB is equal to theta, and LG1 actually this is, right? So DMN, so from this DMN you can also find this is DMN is equal to the angle of LMN minus LMD, so that is G1. So angle of DMN is angle of LMN minus angle of LMD. So LMN is 90 degree and LMD is 90 minus theta, that is simply theta. So to avoid the reaction R, taking moments of all the forces about the point L, then we have this omega A LB is equal to omega B LC, right? So this is A, omega cancel out, A LB and B of LC, right? So from here you can solve that this LC is equal to AD. Check the picture out, that LC is equal to AD. So this obviously, so this is equivalent. From the figure you can see, so LC is equal to AD. So we can write B of LC, we can erase LC and we can put AD over here, right? So here is A of LB, A dot LB. We can write AD in the sense this MD minus MA, okay. So here we have LB is means this LG1 sine theta, which is this equal to B of MD is MG2 sine theta minus LM sine theta, right? So from here LG is half of A, LG1, so we can write half A sine theta, and it is B, where MG2 is half of B sine theta minus LM is A sine theta, okay. So from here we can write A square, right? So we can take out this A square sine theta on the one side, so A square plus 2AB sine theta, and on the other side we have this cos theta, that is B square cos theta. So from here we can write this, what is the tan theta? Tan theta will be B square by A square plus 2AB. So we have to find the angle, okay. So that is the answer of the angle. So our question for 5C is, so determine the angle which the rod LM makes with the vertical direction in terms of the length of the rod. So the angle is, this is simple, tan theta B square by A square plus 2AB. So this goes for question number 5C. So we will solve the next question in the next video, that is 5D.